Welcome everyone. I'm going to talk about Fischer esterification. When a carboxylic acid, for example, is reacted with an alcohol in acidic environment as a catalyst, we will form an ester. Plus water. So this reaction is a reaction that happens in steps. And mostly, we have to know that it is a nucleophilic additional elimination reaction. And it happens when the OH group in the carboxylic acid is replaced by OR group from the alcohol to form an ester. The reaction is very slow and it is always carried out under reflux using sulfuric acid or phosphoric acid as a catalyst. So the main things that I'm going to talk about in this video is just the reaction mechanisms involved during this process. And the reaction mechanisms we have is a step-by-step reaction, and we are going to look at it slowly by slowly. So I'm going to start with the reaction mechanism. Now, a carboxylic acid that is having OH molecule attached to it will first be protonated by the acidic medium that we have. So the acidic medium that we have, I'm going to write it this way. I'm going to have a H here bonded to an oxygen molecule that is bonded to a H that is bonded to an R group, and I'm going to call this R pi. This molecule is positively charged and we have a lone pair of electrons found. Now, the reaction that is going to occur here, the protonation is going to be the lone pair of electrons that are found on the carboxylic acid, the oxygen here. This oxygen has a lone pair of electrons. So the protonation process is going to behave this way. They are going to pick this hydrogen here, and when that hydrogen is picked, an electron is going to be donated back to oxygen, and I'm going to form a unique substance that is drawn or sketched this way. I'm going to have my R that is bonded to a protonated oxygen, and the oxygen is still having a single lone pair of electron. Then now I'm still having my OH attached to the molecule. Remember that OH is the one that is supposed to be replaced at the end of the day. Now, since I'm having alcohol within the system, this is the reaction that is going to occur. The alcohol has an oxygen with the lone pair of electrons. So a nucleophilic substitution is going to occur here, in which the lone pair of electrons found on that oxygen are going to be donated to this chiral carbon here, the carbon center, and the pair of electrons that are forming the double bond are going to be shifted on oxygen. And when that occurs, let me sketch this very well. Yes, when that occurs, I'm going to form a molecule that is unique, and I'm going to sketch it. The molecule that I'm going to form is R, that is bonded to OH, and it is still bonded to a unique molecule still. So I'm going to have O, H, R, a positive here. Then I'm going to have my OH molecule. Now, that's the molecule we are going to form as the reaction proceeds. Now, I'm still having alcohol in the solution. So what is going to happen is the reaction is still reversible. So the alcohol that I'm still having in the solution with an oxygen. Now, the oxygen that I have on alcohol is still going to attack the molecule that I've formed. So what is going to happen is this. I'm going to have a situation whereby this oxygen is going to attack the hydrogen, and a pair of electrons is going to be donated back. The molecule I'm going to form at the end of the day is a funny molecule that looks like this. The reaction proceeds. I'm going to have my R that is bonded to OH, the original OH. Then on this other side, I'm going to have my OR because hydrogen was removed. Then on this further end, I'm going to have OH to the lone pair of electron, lone pair of electron, lone pair of electrons. Now, a proton transfer is going to occur, the next stage. The reaction is still occurring, not done. We're still proceeding with the reaction. So a proton transfer is going to occur, in which we still have that substance in solution. And now proton transfer is going to occur, in which a lone pair of electron is going to attack this hydrogen. And when that one happens, an electron is going to be donated back here. And we are going to form a new substance. And the name of the new substance is going to be a funny substance, because the key thing is we want to make one of the OHs a better living group. The OH of interest here is this OH here, this OH. We want to make it a better living group. So for us to do that, electron transfer must occur during that reaction. So when that happens, I'm going to form a unique type of substance that I'm going to sketch. And I'm going to have my R that is bonded to. Now, because this OH picked a hydrogen from the acid, now what is going to happen? I'm going to form a water molecule, because water molecule is a better living group. So I'm going to have OH2 that is partially positively charged. Then the rest of the molecule is going to stand. On this other side, I'm going to have OR. Then on this end, I'm going to have OH. Lone pair of electron here, a lone pair of electron here. Now, we have a lone pair of electron here, lone pair of electron on that oxygen. So when such also happens, now elimination of water is going to take place. So how is that going to occur? Now the funny thing that is going to happen here, the lone pair of electrons are going to be shifted here. This is going to make water to be expelled out, because between OH and OH2, water is a better living group. So water will be expelled out. So when that happens, what are we going to have? We are going to have a situation whereby the reaction is still proceeding, because we've not formed an ester still. So I'm going to have still alcohol in the system. And now the alcohol that I have in the system will react with the substance that I'm going to form at the end of the day here as R. When water was expelled, I remained with R, OR, and on this end I was having oxygen, the partial positive charge H. Then that one came into being. So the key thing that we have to know, the lone pair found on oxygen here is going to assist me to come up with the final product that I want. Now, what is going to happen? This hydrogen is more polarized. So when electrons in hydrogens are withdrawn, the hydrogen will have a partial positive charge. So it is easily attacked. Now, that one is going to make electrons to be drawn back into the molecule of oxygen. So when that happens, at the end of the day, I'm going to form a new substance, and my new substance is going to be sketched this way. The new substance I'm forming now is a R that is bonded to OR. A double bond is created. Then I'm having oxygen. Now this my oxygen is having lone pair of electron here, lone pair of electron, lone pair of electron, lone pair of electron. So if you look at this substance that I've sketched here, this is my ester. This is now the ester of interest that I wanted. Now, I did not indicate, but during this process, H2O is also formed. Now, I've formed my ester. So the key things that we need to familiarize ourselves with during this reaction are the steps involved. So, in the first stage, which is step 1, I was having protonation reaction. In my step 2, I was having nucleophilic substitution. Now in my step 3 here, I was having proton transfer. My step 4 is still proton transfer. Step 5 here. Step 5 is elimination of water. And lastly, step 6 step 6 is deprotonation. That is yielding our ester. Thank you very much. That's a simple reaction mechanism involved during Fischer esterification.